Here is a little mystery before we start. If you have a horizontal water pipe that is partially filled, the surface of the water forms a flat line across the circular pipe. Hold that thought, because today it becomes mathematics. Welcome to Math Concepts Made Easy. Today is day 17, and our lesson is all about chord properties. Before we start, a quick recap. In our last lesson, day 16, we studied midpoint theorem, statement, proof, converse, applications. If any of that feels unclear, pause here and re-watch day 16 first, because today builds directly on it. By the end of this lesson, student understands that circle chord theorems are entirely based on the perfect mirroring and symmetry of a circle. Grab a notebook, get comfortable, and let us begin. Before we touch any formulas, let me show you where this idea already lives in your everyday life. If you have a horizontal water pipe that is partially filled, the surface of the water forms a flat line across the circular pipe. This flat line is called a chord. If you drop a plumb line straight down from the exact center of the pipe, where does it hit the water? You have been using this idea all along. Today we simply give it a name and learn its rules. So what is really going on here? A circle is the ultimate shape of symmetry. Because of this perfect balance, if you draw a straight line from the exact center so that it hits a chord at a 90-degree angle, it has no choice but to hit the exact middle of that chord. It splits it perfectly in half. If you understand this symmetry, you never have to memorize the theorem. Keep that picture in your mind, because everything else in this lesson grows out of it. Now we are ready to say this precisely, the way mathematicians do. Here is our focus for today: equal chords, perpendicular from center, distance. In symbols, we write it as if a line from the center is perpendicular to a chord, it perfectly cuts that chord in half. Every word of that definition matters, so read it slowly. You already know circle basics: radius, diameter, Pythagoras theorem. This definition simply builds on those familiar ideas. Here is the key formula for chord properties. The formula is, if a line from the center is perpendicular to a chord, it perfectly cuts that chord in half. Watch how each part appears as I say it. Do not just memorize the symbols, make sure you understand what each one represents, because that is what the exam really tests. Let us put this to work with real examples, one step at a time. Circle has radius 5 cm, chord is 3 cm from center. Find the length of the chord. Step 1. Draw the hidden right triangle. Hypotenuse, radius, equals 5, height equals 3. Step 2. Pythagoras, which means 3 squared plus x squared equals 5 squared, which means 9 plus x squared equals 25, which means x equals 4. Step 3. The chord is bisected, so total length equals 4 times 2 equals 8 centimeters. Notice how every line follows logically from the one before it. That habit, checking each step, is what makes your answers reliable. Now, a quick warning, because I see students lose marks on this every single year. Before I show you, think about what could possibly go wrong here. 3, 2, 1. Assuming a NY line from the center cuts the chord in half. Emphasize the 90-degree angle. Without the 90-degree perpendicular intersection, the symmetry breaks and the chord is not bisected. Compare the wrong way and the right way on screen, and promise yourself you will never fall for this one. Time to try it yourself. Here is your practice question. Radius equals 13, chord length equals 24. Find distance to center. Half chord equals 12. Pause the video now, or take a few seconds with me. 5, 4, 3, 2, 1. Okay, let us solve it together. Pythagoras, d squared plus 12 squared equals 13 squared. D squared plus 144 equals 169, which means d squared equals 25, which means d equals 5. How did you do? If you slipped anywhere, rewind and watch that step again. That is exactly how strong students learn. Let us bring today's lesson together in one picture. At the center of everything sits chord properties. We explored equal chords, perpendicular from center, distance. The one formula to remember is if a line from the center is perpendicular to a chord, it perfectly cuts that chord in half. Watch out for the common trap we discussed. And remember our goal: student understands that circle chord theorems are entirely based on the perfect mirroring and symmetry of a circle. Next lesson, angle subtended by arc, inscribed angle theorem, angle at center versus circumference. New lessons every day on math concepts made easy. Thank you for learning with me. See you tomorrow.